In this video, we're going to describe the top 5 features of a data engine. So first, what is a data engine? A data engine is a data processing framework that converts raw data into events. Raw data can include data such as machine data, operational software data, sensor data, work logbook data, and etc. Typically, they are time series data. They are unstructured, very messy, very difficult to work with. Events are structured data that describes all the important, meaningful events that happens inside the raw data streams. And the events can be used in data warehouse, in operational and business intelligence analysis, and in other applications. A data engine typically has 4 components. The first one is a data pipeline. Data pipeline is used to collect the raw data, cleanse the raw data, validate it, and add metadata, etc., to turn it into a structured data type. Data fusion is the next step, which typically combines multiple data tags or data streams so that it completes all the information within the data available. The next step is data analytics, where users apply physics or AI-based type of models to extract the events out of the raw data. And the final stage is producing those events and store those events in a database or data warehouse. The first benefit of a data engine is reducing data complexity. So if we look at time series data, for example, typically, it's a time-stamped series of data that comes in every, second or every certain period of time. And this example shows a time series data, and you can clearly tell that there's something going on here, right? So there's an event here. But just by looking at the time series data itself, you may not be able to tell what that is. So what the data engine does is extracting that event from the time series data, and very often not necessarily one data tag, but it could combine many data tags, describing that process into one event. So here, the event, as an example, could be a production run, and the event could be composed of properties such as whether if the run is successful, how long the run took, who is the operator, what are the different warning codes in the process, what's the efficiency of this process. So we are converting essentially possibly many raw data tags into one event data tag. And that significantly reduces the complexity of raw operational data into something that's very structured and very clear, describing the meaningful event that's inside the data. And this is very important because otherwise it's very difficult for engineers and data analysts to analyze operational data. The second benefit that comes along is a reduction in data volume. You may say, does that really matter? Today's data lakes are fairly cheap. You can store a lot of data. So would data volume reduction be a huge advantage? The answer is yes. The reason for that is because, sure, data is relatively cheap today. But if you're sending data every few seconds, constantly, day after day, over years, the data volume is still huge and is very costly. In fact, the majority of industrial processes that we know of, they don't store all the data in the data lake. They store a lot of this data in like a file storage system such as Amazon S3, because file storage is much cheaper. Therefore, data volume matters, data bandwidth transfer cost matters. And by converting raw data into events, you can reduce the amount of data by a factor of 1,000 or 10,000, depending on how often the event occurs. So that's a really big reduction in the amount of data, which also leads into faster and simpler insight extraction process. So the next benefit is that once you have the events, it is very easy to perform things like BI analysis. So when we think about a data engine, right, it takes in raw data, converts raw data into events, and we build this events data layer, or EDL, that's basically stores all the events into a database or data warehouse. And this data directly you can get real-time alerts out of, but you can also perform very powerful BI now. So BI includes historic type of analysis to answer questions like, what is overall efficiency over time? How are the performance of the operators? Which machines require tune-up? And what are the error codes? Why do they happen? How do we prevent them? So the BI analysis dig into the in-depth of what happens in the operation so that you can improve the operational processes to achieve a better outcome. So it's very important to be able to produce BI analysis. It's very difficult to do BI analysis directly on the raw operational data. But once you convert the operational data into events, then BI analysis becomes very simple. The next benefit of a data engine is that it's a framework that allows you to perform DataOps type of solution development very quickly and at a very high performance. So a typical DataOps engine, for example, is visual so that your solution is observable. That makes it simpler to do development. It's typically modular and hierarchical so that you can, reduce the complexity of your design through modular and hierarchical architecture. It is self-documenting because when it's visual, you can see the flow of your data operations so that you can understand what you're doing, even without being a expert in software coding. Typically, a data engine has a very, very powerful architecture behind it. For example, maybe the architecture is asynchronous, which means that the data engine is not consuming memory or CPU when there's no data coming in, and it only consumes resources when there is data coming in. So it's very resource efficient. But at the same time, if there's a lot of data coming in, it can spin off jobs into containers that run independently and then return the results back so that you can scale to very large data operations. And typically, data engines need to support physics and AI type of models because converting from raw data into events often require advanced analytics models. And finally, you want a data engine that gives you versioning that can track data lineage so that you can go back to understand, when and how you've changed your data solution to keep track of any issues. The last benefit I'm going to talk about is really when you scale your data engine into a distributed architecture. Sometimes you can call this a data mesh architecture, where you can have many different data engines running to serve different data sources. Some of the data sources may be in the cloud, like a data warehouse or data lake. Some of the data sources may be at the edge, in a plant, at a refinery, and etc. This is because for most organizations today, data doesn't reside in one place. Data is distributed in many places, and very often you cannot collect all the data into the same place due to security, privacy, or other type of concerns. So then the strategy is to bring data engines down to where your data is, within the firewall, within the protection, so that you can process the data in those local environments and send out the insights, which typically is not doesn't have nearly as much privacy concerns and combine all that together from all your data sources into a comprehensive type of data insight solution. So this is very powerful, and this allows you to scale to very large organizations, very large DataOps to serve your physical operations and processes. So this is a very short intro on the top benefits of a data engine. And then in the future, we can describe the benefits as well as architecture in more detail. If you have any questions, please contact us. Thank you.